Hello guys, welcome to lesson 1-6, which will be on solving equations with variables on both sides. Now, I want to apologize ahead of time for my voice is very rusty right now because I just had fourth period and we were playing a game for review and they were very excited. So my voice is almost gone. Alright, but I'm going to try my best. Alright, so let's go ahead and get started. Your vocabulary word for today is identity. So we all know that when we are solving variables, when we are solving equations, we want to keep all the variables on one side and all the numbers on one side. Previously, we have been dealing mostly with variables on one side, but this time we are going to see variables on both sides. Now the only difference is here we want to make sure we collect all the variable terms to be on the same side of the equation and then keep all the constants on the other side of the equation. So let's go ahead and do this first example. Alright, so first thing that we want to do here is to go ahead and collect like terms. Let me go ahead and want to write on this. Now, one of the things that I want to say is that when we are moving the variables, so for example, we have a 7n over here and a 5n on this side of the equation. So we want to make sure we put all the n's on one side and all the constants on another side. So it is easier if we do not have any negative numbers. So be very careful on deciding on which side you want your variable to be on. So for example, here I see 7 is bigger than 5, and to move 5n, please remember that this is a positive 5n. So for me to move it, I have to do the opposite, which is to subtract 5n on both sides. Notice I'm not putting 5n below the -2. I'm putting 5n below the 7n because they are like terms. So these will cancel. And on this side, we will have 2n minus 2 will equal to 6. Now here, this now become an easy two-step equation. Let's move the 2 on the other side by doing again the inverse operation, and we have 2n is equal to 8, and divide both sides by 2, and we have n is equal to 4. Again, this is not so difficult. All we are doing is collecting all the terms with the variables to be on one side. Alright, go ahead and try one. Alright, so go ahead and try this one and then come back and get the answer. Alright, welcome back. So here again, I see the 3b is over here. So best thing to do is to move the 3b to be with 4b so we do not end up with a negative. Alright, so since this is positive 3b, we need to subtract 3b. And 3b minus 3b will be 0. And now we just go ahead and add 2. And then 4b minus 3b is 1b, but remember we do not write the 1. And then now this become a easy one-step equation. And we have b will be -2. Okay. Alright, so now we are going to move on into a little bit more complicated equations where we have to distribute before we can combine. Alright, so let's go ahead and do this one. Let me switch to pen. Alright, so here what we want to do again is to collect, but I see here that there's a -5. I have to do -5 times the quantity of 7 minus 2a. So I want to make sure I distribute the -5 before I do anything. So I'm just going to write everything on this side of the equation because I haven't touched it yet. Now I'm going to distribute. So it's negative 5 times 7, and that'll be negative 35. Again, be very careful with your signs. And negative 5, which is the negative 5 times 7, negative 5 times negative 2a, and that'll be positive 10a. Alright, so now I can go ahead and start. Actually, here, before we can do anything, we can actually collect these terms before we move them. So over here, I see that I have a negative 6a and a positive 4a. So let's go ahead and collect them. So negative 6 plus 4 will be negative 2a. And over here, I can collect those guys, the regular constant. So negative 1 minus 35 will be negative 36 plus 10a. Alright, so now I'm going to move. Now it doesn't matter which way you move things, but try to always move the smaller number. So in this case, I have 2, I have negative 2 and positive 10. So let's move the negative 2 by doing the opposite. So it's going to be 2a. And these will cancel, and we have 4 will equal to negative 36 plus 12a. Now this become an easy two-step equation. We add 36. Again, be very careful with the signs. And 4 plus 36 is 40. And then here we go ahead and divide both sides by 12. Alright, and that will be 3 1/3, so we can say 3 1/3. Alright, so let's do one now with fractions. Now, just because we see fraction does not mean that we need to start panicking. Okay, so here all I have to do here, this is saying to take half of the quantity of b plus 6 is equal to 3/2 of b minus 1. So first thing here, I want to go ahead and distribute the half to everything inside the parentheses. So half of b will be half, and half of 6 will be positive 3. Now we could just get rid of the halves by getting rid of the fraction, but in this case everything have the same denominator, so we can just go ahead and keep them. So first thing I'm going to do, I'm going to move the half. I'm going to do subtract half of b, and I'll be left with 3 on this side, and then 3 minus 1 is 2, and 2 divided by 2 is 1. So I'm left here with b minus 1, and then now this become an easy one-step equation. Alright, so again here what we did was first take half of b, take half of 6, which is 3, and everything else stay the same. Now I move the half because half is smaller than 3/2. This is actually 1 1/2. Alright, so it's 3 1/2 minus half, which gives me 1. Notice I did not put the 1 in front of this b. We already know there's a 1b there. And then from there we just solve. Alright, so your turn. Go ahead and try this one. Pause, come back and get the answer. Alright, welcome back. So here's the answer. So first thing we want to do is distribute. Be very careful. Alright, and then we end up with 3x minus 15. Now we did not do anything on this side, so it stays the same. We only touch this side, and we will end up with 2x plus 4. Now we can go ahead and combine like terms. Again, these are like terms. They're just constants. So we can put them together before we move anything across the equal sign. And now we can move the 2x to be with 3x. We get x. Again, we have to do the opposite operation of this is a plus 2, so we need to do minus 2x. And then we can clearly see that x will be negative 2. Okay? Now, what is an identity? So an identity is an equation that is true for all values of the variable. An equation that is an identity has infinitely many solutions. And we also have equations where we do not have any solutions at all. Those are usually called false equations. Alright, so this is the case of an identity. So sometimes when we solve for an equation by moving things around, we end up with 2 equal 2. So since 2 is equal to 2, so that will be an identity, so that will be an infinite solution. So for no matter what number I put in here, this equation will always be true. If I put in 5 and 5 over there, 2 plus 5 is 7, 2 plus 5 is 7, so it will always be true. If I plug in 1,000, 2 plus 1,000 is 1,002, 2 plus 1,000 is 1,002. So this one has infinitely many solutions, and the symbol for infinity is, alright, so if we want to say this has infinite solution, so we can write like this, from negative infinity all the way to positive infinity. Alright, now we have the case of the false equations where we end up with something like this. After we solve the equation, I subtract x on both sides, and x minus x is 0, and I end up with 0 equal to 3. That is false. So that means this equation have no solution. There's no way I can plug in a number. For example, if I put in 1 into that equation, it will not be true. So if I alright, so here let's do an example. So here, first thing we want to do here is to go ahead and combine the like terms. So we have 10 and 1. 10 plus 1 will be 11 minus 5x is equal to, and then here I can put these guys together. So 7 minus 12, which would be negative 5, so that'll be negative 5x plus 11. Alright, so now we can go ahead and move things around. So when I go ahead and move the 5x, if you look, these are inverse. So if I have negative 5 plus 5, that's 0. So x cancel, I end up with 11. And over here we have negative 5 plus 5, that's 0. And here we have 11. So this one right here will be an identity. And this one has infinite many solution. And another way for us to write this is we can go from negative infinity all the way to positive infinity. Okay, very easy. Alright, so here let's do another example. Now again, here we want to do the same thing, which is to collect like terms. So we want to go ahead and collect like terms here. So 12x and x will be 13x minus 3. And then over here we do 5x plus 8x, which is 13x minus 4. Now I'm going to go ahead and move my 3. Actually, let's go ahead and move 4 so we do not end up with negative. So we have 13x, and then negative 3 plus 4 will be positive 1 is equal to 13x. Now I have to move this 13x to be with the other one. And here I end up with 1 is equal to 0 because 13 minus 13 is 0. So in that case, this one will not be true and this one will have no solution. Okay, so there's no solution for this one. Alright, and that's how. Alright, go ahead and do this one by yourself. Pause and then come back and get the answer. Alright, here's the answer. So again, we want to collect like terms by doing 4y, putting 4y and negative y together, and then we will end up with 3y plus 7 is equal to 3y plus 10. And then subtracting 3y on both sides. Alright, so my y disappear, my variable disappear, and then we end up with 7 is equal to 10, which is not true. So this equation here has no solution. So the original equation has no solution. Alright, go ahead and try this one. Alright, again, combining like terms, we end up with 3c plus 7 is equal to 3c plus 7. Now we can already see from here this is an identity because it's the exact same equation. And we end up with 7 is equal to 7. So this one will have infinite solution. Alright, so that will be all real numbers will be solution all the way from negative infinity to positive infinity. Alright, that was it for today. I try to do it quickly because I like to do a lot of I like to do a lot of examples, so hopefully this wasn't too bad. Have a good one. Bye bye.